The National Electrical Code, or NEC, applies to electrical installations after the service point. This service point is specifically defined in NEC section 230.2. It's the demarcation between the utility's responsibility and the building owner's responsibility for electrical wiring. When we talk about overhead clearances and underground depth specifically for the utility's infrastructure, these are generally governed by the National Electrical Safety Code, or NESC. The NEC typically does not cover these aspects of the utility's distribution system. The utility company is obligated to adhere to the NESC when performing work on their facilities, even when those facilities are located on private property. This is often due to easements or rights of way that grant the utility access and the authority to maintain their equipment. The NESC provides detailed specifications for clearances, grounding, and other safety requirements related to utility-owned infrastructure. The NEC, on the other hand, focuses on the electrical systems within buildings and on the customer side of the service point. To understand this better, let's delve into the specifics of the NEC and NESC. Firstly, the NEC, formerly known as NFPA 70, is a widely adopted code for the safe installation of electrical wiring and equipment in the United States. It's updated every 3 years to incorporate new technologies, safety practices, and address emerging hazards. The NEC covers a broad range of electrical installations, including residential, commercial, and industrial settings. It provides detailed requirements for wiring methods, overcurrent protection, grounding, equipment installation, and many other aspects of electrical systems. The NEC is enforced by local and state authorities, and electrical inspectors use it to ensure that electrical installations meet minimum safety standards. Section 230.2 of the NEC defines the service point as the point of connection between the serving utility and the premises wiring. This point can vary depending on the specific installation and the utility's practices. It may be the termination of the overhead service drop or the underground service lateral. Everything on the load side of the service point, meaning the wiring and equipment within the building, is subject to the NEC requirements. Secondly, the NESC, published by the Institute of Electrical and Electronics Engineers, or IE, sets the standards for the construction, operation, and maintenance of electric power and communication utility systems. It covers overhead and underground lines, substations, and other utility facilities. The NESC is primarily concerned with the safety of utility workers and the public in proximity to utility infrastructure. It addresses issues such as conductor clearances above ground and other objects, pole strength, grounding practices, and worker safety procedures. The NESC is often adopted by state regulatory agencies and utilities themselves as the governing standard for utility operations. When a utility company has an easement on private property, that easement grants them the right to access and maintain their equipment. This includes the right to install and maintain overhead lines, underground cables, and other facilities. The utility is responsible for ensuring that these facilities meet the NESC's requirements regardless of whether they are located on public or private land. The property owner is typically not responsible for ensuring compliance with the NESC for utility-owned equipment. However, they may have obligations to avoid interfering with the utility's facilities or creating hazards that could affect the safety of the system. Consider an example of an overhead power line running across a property. The NESC specifies the minimum vertical clearance required between the power line and the ground, buildings, and other objects. The utility is responsible for maintaining this clearance to prevent accidental contact or other hazards. If a property owner were to build a structure that encroached on this clearance, the utility would likely require them to modify this structure to comply with the NESC. Another example involves underground cables. The NESC specifies the minimum burial depth for underground cables to protect them from damage and prevent electrical hazards. The utility is responsible for ensuring that the cables are buried at the proper depth. If a property owner were to dig near the cables, they would need to follow safe digging practices and contact the utility to avoid damaging the cables. The interaction between the NEC and NESC is crucial for ensuring electrical safety. The NEC focuses on the building's electrical system, while the NESC focuses on the utility's infrastructure. By adhering to both codes, electrical professionals and utility workers can create safe and reliable electrical systems for homes, businesses, and communities. To summarize, the NEC applies to electrical installations after the service point, as defined in NEC 230.2. Overhead clearances and underground depths for the utility are specified in the NESC and are not covered by the NEC. The utility is required to follow the NESC for work on their facilities on private property. The NESC states that the NEC applies to building utilization wiring. The NEC, or National Electrical Code, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It's updated every 3 years by the National Fire Protection Association, or NFPA, to reflect the latest advancements in technology and safety practices. The NEC covers a wide range of electrical installations, from residential wiring to industrial power systems. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and equipment installation. One of the key concepts in the NEC is the service point, which is defined as the point of connection between the serving utility and the premises wiring. This is the point where the utility's responsibility ends and the building owner's responsibility begins. The NEC applies to all electrical wiring and equipment on the load side of the service point. This includes the wiring inside the building as well as any outdoor wiring that is connected to the building's electrical system. The NEC also covers the installation of electrical equipment, such as lighting fixtures, appliances, and machinery. It specifies the proper wiring methods, grounding requirements, and overcurrent protection for each type of equipment. The NEC is enforced by local and state authorities, and electrical inspectors use it to ensure that electrical installations meet minimum safety standards. Electrical contractors are required to be familiar with the NEC and to follow its requirements when installing electrical wiring and equipment. The NESC, or National Electrical Safety Code, is another important set of standards that governs the safety of electrical utility systems. It's published by the Institute of Electrical and Electronics Engineers, or IEE, and is updated every 5 years. The NESC covers the construction, operation, and maintenance of electric power and communication utility systems. It includes requirements for overhead and underground lines, substations, and other utility facilities. The NESC is primarily concerned with the safety of utility workers and the public in proximity to utility infrastructure. It addresses issues such as conductor clearances, pole strength, grounding, and worker safety procedures. One of the key differences between the NEC and the NESC is their scope. The NEC applies to electrical installations within buildings and on the customer side of the service point, while the NESC applies to electrical utility systems on the utility side of the service point. This means that the NESC covers the electrical infrastructure that delivers power to homes and businesses, while the NEC covers the electrical wiring and equipment within those buildings. Another important difference is that the NESC is typically enforced by state regulatory agencies, while the NEC is enforced by local and state authorities. Utility companies are required to comply with the NESC when constructing and maintaining their electrical systems. The NESC also specifies the minimum clearances required between overhead power lines and the ground, buildings, and other objects. These clearances are designed to prevent accidental contact with power lines and to ensure the safety of the public. The NESC also includes requirements for grounding electrical systems to protect against electrical shock. Grounding helps to ensure that electrical faults are safely cleared and that the voltage on electrical equipment is maintained at a safe level. The NESC is an essential standard for ensuring the safety of electrical utility systems. By following the NESC's requirements, utility companies can protect their workers and the public from electrical hazards. When a utility company has an easement on private property, the easement grants them the right to access and maintain their equipment. This includes the right to install and maintain overhead lines, underground cables, and other facilities. The utility is responsible for ensuring that these facilities meet the NESC's requirements, regardless of whether they are located on public or private land. The property owner is typically not responsible for ensuring compliance with the NESC for utility-owned equipment. However, they may have obligations to avoid interfering with the utility's facilities or creating hazards that could affect the safety of the system. For example, if a property owner plants trees near overhead power lines, they may be required to trim the trees to maintain the required clearances. Similarly, if a property owner digs near underground cables, they must contact the utility to locate the cables and avoid damaging them. The NEC and the NESC are both important standards for ensuring electrical safety. The NEC covers electrical installations within buildings, while the NESC covers electrical utility systems. By following these standards, electrical professionals and utility workers can create safe and reliable electrical systems for homes, businesses, and communities. Let's consider some specific examples to further illustrate the application of the NEC and NESC. Imagine a homeowner is building a new detached garage on their property. The electrical wiring in the garage, including the wiring for lights, outlets, and any appliances, would be subject to the NEC. The homeowner would need to hire a qualified electrician to install the wiring according to the NEC requirements. This would include using the correct wiring methods, providing adequate overcurrent protection, and ensuring proper grounding. If the homeowner wants to run power from the main house to the garage, they would need to install a feeder circuit. The NEC specifies the requirements for feeder circuits, including the minimum wire size, the overcurrent protection requirements, and the grounding requirements. The homeowner would also need to obtain a permit from the local building department and have the electrical work inspected to ensure that it complies with the NEC. Now, imagine that the utility company needs to install a new overhead power line across the homeowner's property to serve a new subdivision. The installation of the power line would be subject to the NESC. The utility company would need to ensure that the power line meets the NESC requirements for conductor clearances, pole strength, and grounding. The utility company would also need to obtain an easement from the homeowner to allow them to install and maintain the power line. The easement would grant the utility company the right to access the property to perform maintenance on the power line. The homeowner would be required to avoid interfering with the power line or creating hazards that could affect its safety. For instance, the homeowner would not be allowed to build a structure onto the power line that would violate the NESC's clearance requirements. In another scenario, consider a commercial building with a large electrical service. The electrical wiring in the building, including the wiring for lighting, HVAC systems, and machinery, would be subject to the NEC. The building owner would need to hire a qualified electrical contractor to install and maintain the electrical system according to the NEC requirements. The electrical contractor would need to be familiar with the NEC requirements for commercial buildings, which are more stringent than those for residential buildings. The building owner would also need to have the electrical system inspected regularly to ensure that it continues to comply with the NEC. If the building owner wants to install a solar panel system on the roof, the installation would also be subject to the NEC. The NEC provides specific requirements for solar panel systems, including the wiring methods, overcurrent protection, and grounding requirements. The building owner would need to hire a qualified solar installer to install the system according to the NEC requirements. The solar installer would also need to obtain a permit from the local building department and have the installation inspected to ensure that it complies with the NEC. These examples illustrate how the NEC and NESC work together to ensure electrical safety in different situations. The NEC covers electrical installations within buildings, while the NESC covers electrical utility systems. By following these standards, electrical professionals and utility workers can create safe and reliable electrical systems for homes, businesses, and communities. In addition to the NEC and NESC, there may be other local or state electrical codes that apply to specific installations. It's important to check with the local authorities to determine which codes are in effect in your area. These local codes may have additional requirements or restrictions that are not included in the NEC or NESC. For example, some local codes may require the use of specific types of wiring or equipment, or they may have more stringent grounding requirements. It's also important to note that the NEC and NESC are constantly evolving. New editions of these codes are published every few years to reflect the latest advancements in technology and safety practices. Electrical professionals and utility workers need to stay up to date on the latest changes to these codes to ensure that their work complies with the current requirements. There are many resources available to help electrical professionals and utility workers stay informed about the NEC and NESC. The NFPA offers a variety of training courses and publications on the NEC. The IE also offers training courses and publications on the NESC. In conclusion, understanding the relationship between the NEC and NESC is crucial for anyone involved in electrical work. The NEC governs building utilization wiring, while the NESC governs utility infrastructure. Knowing which code applies to a given situation is essential for ensuring safety and compliance. Always consult the latest editions of both codes and any applicable local amendments to ensure that your work meets the current requirements.